Okay, it's 6:30, and I think we are good to get started. Hello, everyone. My name is Chenny. I am the president from the Actuarial Students Society. It's good to see everyone here. Quite some number of people I can see. This is a lot. This is our first collab between ASS and the MUMS. I see some familiar names and some non-familiar names. I'm sure you're from MUMS. Welcome, everyone. It's good to see everyone. Before I begin, I'd first like to, I'd first like to acknowledge the traditional owners of the land which we meet today and pay my respects to the elders, both past and present. This is one of our first events, so before the event begins, I'd first like to, I guess, do a bit of an advertisement for both of the societies and actually promote you guys, or I'll ask you guys to join each other's society. So if you're already in the ASS and you've participated through ASS, feel free to go into MUMS and check out their websites, their Facebook pages, and sign up for them as well. From my knowledge, it's free as well, I think, for the semester. Yep. And if you're from MUMS, same for you as well. ASS is actually, the membership is free this semester too. So feel free to come along, check out our website, and sign up for any future events and stuff too. ASS is holding a R workshop, I think just a week after the break. 2 workshops for both beginners and intermediate students. And I'm sure R is something that a lot of maths and stats students use as well as Tactile students. So feel free to come along, join us for the event and learn some insightful tips from our speakers and guests, our speakers. And although from what I've heard, this session is quite full, so you probably should get in quick, but MUMS is also hosting a movie night this Thursday, if I'm not wrong. And this is an in-person event, so you'll have to physically be there. So if you're based in Melbourne, go along. I'm sure we can probably post the links to both of the events in the chat later on if anyone wants to check it out and get themselves registered or sign up for those events too. I think they're watching a beautiful, what's the name?
A Beautiful Mind.
Yeah, Beautiful Mind. That's what it says. Looks cute. I checked out the poster. It looks really cute. Okay. With that, unless there are any more issues, we are good to get started. I'll pass the mic to Rose and Elizabeth, who will be our speakers for today. So I know we can't hear you, but if you guys can just quietly clap for them, that'd be nice.
Thanks,
sorry Rose. We also suggest you have your cameras on and your mics off, just for that engagement part of the side of things. There is also an event feedback form, which we'll speak about a bit later towards the end as well. Thanks, guys.
Thanks, Chinny. Okay, cool. You guys can see my screen, right? Okay, just some housekeeping stuff at the start. During the workshop, if you guys have any questions, please feel free to unmute yourself and speak up. Otherwise, you could also post your questions in the chat. I'm sure there are committee members here to help out answering those questions. And otherwise, for the smooth running of the event, please keep yourself unmuted. Okay. Okay, cool. Let's not get started. So, hi guys, welcome to our introduction to LaTeX and Overleaf. As you know, this workshop is for beginners mainly. So at the start, I'm going to do a brief introduction about LaTeX and also Overleaf. And my name is Rose. Elizabeth and I will be presenting today's workshop. First of all, for those of you who don't know what LaTeX is, it is a typesetting software that allows you to produce very high quality documents. For example, you could use LaTeX to make books, write journal articles. And I know some lecturers and tutors also use LaTeX to make their lecture slides and tutorial sheets. Also, how you could use LaTeX is you could use it in your assignment write-ups. And also something that's worth mentioning is that these slides are also produced using LaTeX as well. And one thing I want to mention about LaTeX is that it allows you to focus on the content rather than the appearance. So what it means is that if you use Word, you could like use different styles of formatting, like arrange the words in different format as you like. However, in LaTeX, it does not give you that much flexibility in terms of the style of your formatting, etc. So it allows you to really focus on whatever the content you are writing. So why do we use LaTeX? Here are just some examples of assignments from our committee members. As you can see here, LaTeX allows you to, it's very easy to use LaTeX just in writing these mathematical equations. For example, you can see these actuarial symbols and also the integration signs and also summation signs. And here is a limit. Okay, and here is another one. So again, there are a lot of mathematical equations. So it allows you to produce your assignment in a really neat way, in a really neat style of formatting. Okay. Since LaTeX is a software, in order to use LaTeX, you do need to download it and install it onto your computer in the first place. So there are two softwares that you need to download. The first one is the LaTeX software itself, and you can download it through this website. And the other one is TeXmaker, which is a LaTeX editor. However, in today's workshop, we will not be using LaTeX. We will be using Overleaf instead. So what Overleaf is it's an online LaTeX editor. It's sort of like Google Doc for Word. So it allows multiple people to collaborate on the same document at the same time. And also another good thing about Overleaf is that when you create documents, sometimes you need to use a package. And if you just use LaTeX, you will need to download the packages onto your computer beforehand. However, if you want to use Overleaf, you can just use the package straight away without downloading it onto your computer. Okay, so how to use Overleaf? I have already mentioned this at the start when everyone was coming in. So to use Overleaf, it's quite simple. You just go to overleaf.com and register for an Overleaf account. So if you haven't done so, please do it now, because the main part of our workshop is about to start in a second. Okay, and it's free. So do it if you haven't. Okay, so that was pretty much it for the introduction bit. And here are the things that we will be covering in today's workshop. And first of all, we will create our very first Overleaf file or Overleaf document. And also, at the end, we are going to have some capstone exercises for you to try out on your own as well. Okay. So I think most of you should arrive at this page once you have registered for an Overleaf account. So let's now create our very first Overleaf project, and we could name it my first Overleaf project, and then create. Okay, cool. You will probably arrive at this page. So once you have created your first project, Overleaf automatically gives you a certain structure of your first document. You could just compile the document and see what it looks like. And there are a few things that you could recognize, right? The first one is my first overleaf project. It is the name of your project. And the second one should probably be your username or your name. And after that is the date of today, which is March 2021. And after that is a heading, which is introduction. Okay. So now let's go back to the source code and let's go through the codes one by one. So the first line is document class and it's an article. In LaTeX or in Overleaf, whenever you are creating a file, it is the first line that you should write. It is you telling LaTeX that what type of document you want to produce. And in this case, you want to produce an article. So the type of your document is an article. And you could change it to other different types as well. For example, you could change it to a book and then recompile it. It would appear as a different style of formatting. So it's like a book. And also another one is Beamer. It looks quite different from the other ones. This would probably be familiar to you if your lecturer used this as your lecture slide. So this is usually used in your lecture slides, I think. Okay, but for today's workshop, we will be using an article because that's the most frequently used, typically used one. All right. So the next line we are looking at is use package, and the package we're using is called this. For this workshop, you don't need to worry about this line. If you have heard about ASCII codes, it is to do with converting non-ASCII codes into ASCII codes. However, we don't need this line. For today's workshop, we could either delete it or just comment it. Okay. For commenting in LaTeX, it is the percentage sign. So if you comment something, it does not show up in your output PDF. Okay, so after that, it is the title, the author, and date. As you can see here, you can change the title to however you want. And since this is our first document, we will change the title to hello. I'll change the author to my name. And the date is correct, so we can just leave it there. This is only defining the title. It is not actually telling LaTeX to output the title in the PDF file. So after that, you can see there is the line begin document. And in LaTeX, anything you want to include in your PDF output file, you should put within the begin document and the end document. So you can see that begin document and end document is where our file formally begins, like whatever you want to write formally begins. And the first thing is make title. Make title is you telling LaTeX that you want to include the title, author, and date at the beginning of your output file. So just because you have defined your title, author, and date does not mean that it will automatically appear in your output PDF. So you will have to use the command make title. Okay, so after make title is section introduction. So this is a heading, and the heading is called introduction. Because we will discuss this one in a later section of our workshop today, we don't need to worry about this for now because we will come back to it later. All right, so we can, after the make title, so we already have title, author, and date, we can write whatever we want. So we can type hello world. This is my first LaTeX or Overleaf file. This is a paragraph which contains some random sentences. Okay, you can compile it and see what it looks like. And hopefully this will appear on your PDF document. It all looks very good, very neat. However, once you take a closer look, you will probably notice some difference in your source code and your PDF file. And one thing to note here is that hello world and this is my first overleaf file, they belong to two different lines, like they are not in the same paragraph in your source code. However, in your output PDF, they appear on the same line, right? The reason is because in overleaf or in LaTeX, if you want to, if you only hit return or enter once, it does not give you an extra line. So in order to have an extra line in your output, you need to hit return or enter twice, like this. And then you recompile it. There you would have an extra line for your second sentence. Okay, and another option is 2 backslashes. If you put 2 backslashes after the word hello world and recompile it, you can see the second sentence also appears on a separate line. All right, and also another thing I want to add to my source code is the command set length. So what set length does is that it's setting your indentation to a particular length. And in this case, I want my indentation to 0. As you can see here, now it's setting the indentation to 0. So every start of every sentence now is neatly aligned. Okay, cool. So now you guys have created your very first overleaf file. Now I'm going to show you guys a LaTeX file, a document that's created by our committee members using LaTeX, and that is our Actuarial Students Society subject review. And if you scroll down and you randomly click into a subject, you can see that this is made by LaTeX. It all looks very neat. And there are some things that, some styles of formatting that you might want. For example, some words are bolded out and some words are italicized, right? And you have this percentage sign and you have different colors like blue and red. So now you might want to include different styles of formatting, like different formatting in your overleaf document as well. So let's now create a new file called formatting. Okay, and you click into the new file, it should be empty. Like I said before, the very first line you want to write at the start of every file should be document class. That's defining what type of document you want to produce. And this time, again, it is an article. All right, so after that, I'm going to set the indentation to 0 again. Sorry guys, I'm a slow typer, so please don't judge. Okay, set it to 0. And after that, you want to begin your document. Okay. So the first thing we will do is different sizes, different sizing. So we can have a tiny hello, or a small hello, or a large hello. Also a capital large hello, which is larger than large. And last one, huge hello. As you can see here, you would have hello in your output file in different sizes. All right, now let's move on to some other fonts like text bold font. So you are bolding out the words, and text IT is italicized and underline. So you are underlining the word. Or text SF stands for sans serif. Okay. Text with 3 Ds is typewriter. Okay. Hopefully I haven't made a typo here. Okay, cool. So you can see the first word is bolded out and the second word is italicized and then underlined. This is sans serif and typewriter. Now you might want to include some different colors in your document. The command, the code for different colors is text color. It's like coloring your text. You could have a blue hello, or a green hello. However, if you just compile it like this, it will not output the word hello in blue or green. You can see here, it's treating blue hello as a separate word without making the actual word hello blue. The reason is because in order to use different colors in the text, we have to use a package. So let's now introduce our first package that we will use today, which is Xcolor. Okay, so after you have added in your package, you then compile it, and now you have the word hello in both blue and green. All right. Now, apart from that, you might want to do a color box. And I want a yellow box with the word hello. Recompile it, and there you would have the hello within a yellow box. Okay. After that, let's do some special characters. First one, hashtag, $, percentage sign, ampersand, and also backslash. In LaTeX, if you actually want to include these special characters in your output PDF, it actually doesn't work like this. Okay, see, it doesn't compile. So in order to include these special characters, you would have to use a different command, because these characters actually have a special meaning in LaTeX. So in order to use hashtag, you have to use a backslash. And so it's $, percentage sign, and ampersand. However, for backslash, you need to use 10 text backslash. Now, once you've done that and compile, it would appear on your final output PDF. So a thing that's worth mentioning here is that these special characters have a different meaning. For example, the percentage sign actually includes an equation. So if you want to write an equation, it should be included within $2 signs. For example, 1 plus 1 plus 1. Okay, and the percentage sign, like I mentioned before, it's commenting. So if you want to comment out a line, you just include the percentage sign at the start of the line. Okay, and the ampersand is typically used in tables to separate out the different columns. All right, so after that, let's do some fun stuff. We could do a special symbol of which is a heart suit. Okay, or a diamond suit. Okay, and also you could do a triangle. If you recompile it, oops, did I make a typo? Sorry guys, diamond. Okay, there you would see a heart shape and the diamond suit and also a triangle. Okay, cool. That's it for the formatting. Now, if we go back to our subject review and we scroll back to the contents page, as you can see here, there are different sections. For example, we have first year subjects, second year subjects, and graduate subjects, etc. And within each year level, we also have different headings. So it's a very good way just to structure your document very neatly. Let's now move on to the next section, which is sections. Okay, so let's create a new file. Just like the start of every document, we want to define the type of document that we are writing, which is an article again. And let's just begin document. So let's do the first section called section 1. And section 2. And you can just copy and paste here. Make it section 3. And within each section, we can have different subsections. Subsection 1, subsection 2. And you can place the subsection wherever you like, under whatever section you like. So it can be under section 3. Okay. And under each subsection, you could also have subsections. Right. Let's now recompile and see what it looks like. Now you can see here the sections appears to be larger than the subsections, which appear to be larger than the subsections. And also, LaTeX would automatically number the different sections for you, like 1, 1.1, 1.2. So it's a good way to structure your document. And also, another advantage of using the different sections is that in LaTeX, it makes it very easy to include the table of contents. So to include the table of contents, you use the command table of contents. And because you want the next page to things after table of contents to be on a separate page. So you use, I'm going to use new page here. Recompile it. And you can see the table of contents with the page number, the corresponding page number. Okay. And the second page is your the main body of your document. Okay, cool. And after that, you might want to include some images in your document as well. So for images, today I am going to use the images from here, from this drive. I will send the link to the chat. So you guys can find the images there. If you want to use the same images as me, and I will just upload these images from my computer. So you click upload and you drag the images or PDFs there. And it might take some time to upload. Okay. Now, once you've uploaded your images and PDFs, it should appear in this section. You can find it here. The first one is a cat, and the second one is a cohort trends, and there is a cover of an assignment. Okay. Now we can create a new file called images and PDF. Okay, just like before, the first thing you want to write is document class, and it is an article. You could essentially just copy and paste. Okay. To include the images, you need to use the command include graphics. And the width can be the text width. And inside the curly brackets, you want to put in the name of your image. This should be cat.jpg. However, in order to include an image in your LaTeX file, you actually need to use a package called graphics. And it should be graphics. Second one. You can compile it, and hopefully it should appear. Okay, yes, it does. And you could do it to the second image as well. The name is cohort trends. And there you would have your second image below the first one, which is changes in actual cohort trends. Lastly, let's include the final PDF. You don't want to use include graphics, but instead you want to use include PDF. Inside square brackets, you include the number of pages you want to include. And the name is cover.pdf. Okay. Recompile, if you haven't made a typo, then the first image should appear, and so should the second one. And also, did I make a typo? I think I did. So, oh, right, sorry guys. I forgot to mention, in order to include the PDF, you need to use a package called PDF pages. Now, once you recompile again, you should have the page of your assignment cover sheet. Okay, cool. All right, all good. So next thing, we might want to include a table. Just like before, I'm going to create a new file called table, which is here. Document class, and should be article. And for this one, to make it look nicer, I'm going to include a title called tables. After that, let's begin document. So you have defined your title. In order for it to appear in your PDF output file, you need to use the command make title. That's something we've mentioned at the start. Okay, so to create a table, you can use the code begin tabular, which is the second one. And you can just hit return, and you will see there that overleaf automatically give you a certain structure of your table, which is very convenient. Let's go through the commands, the codes one by one. So the first line saying you want to include a table, and the 2C just means that you want 2 columns, and you want the 2 columns to be center aligned. If you want them to be right aligned or left aligned, you can change the C to ROL. This one, I will just use center aligned, so I will change it back to C. Okay, after the first line, the second line is where the table formally begins. You can put in whatever you want inside your first row, first column. And after that, you can see there is an ampersand. I think I've mentioned this before. An ampersand in tables means where you want to separate the 2 columns. So you want inside the first row, you want the first row, first column to be 1, and you want the first row, second column to be maybe a 2. This could be 3, and this could be 4. And at the end, I would include 2 backslashes just telling Overleaf that you want to end the row. Hopefully it will compile. Yes, it does. You can see there is the title and the date, and there is your table. However, just looking at this, it doesn't look very nice because it only has a vertical line and it doesn't have all of the other borders. So in order to include the borders to make it look nicer, you can use the vertical bar to, it's like drawing out the vertical lines. And the vertical bar should be located on your keyboard, should be the same key as your backslash. So you should hit Shift and then the backslash. Okay, so in order to include a horizontal line, you need to use the command hline. And in this case, we need 3 lines. Okay. Once you've done that, recompile, and there you would have a table of a 2x2 table with all of the borders drawn in. So this is quite a simple table. It's just showing you like the different codes of making a table. Before this workshop, I have already made a separate table which looks like this. So I think you already have the toolkit of making a table like this. It's something that you could do in your own time. I will not go through it with you today for the interest of time. All right, now let's look at something a bit more exciting. Let's make a new file called Actuarial Symbols. Create. And again, it's a blank document, and you want to define the type or the class of your document. And I will set the indentation to 0. Also, if you want to include any actuarial symbols, you need to use the package called Actuarial Symbol. Also, just to make it look nicer, I am going to include a title. And after that, let's begin document. The first line, you want to include your title, right? So you want to do make title. And then after that, I'm going to make everything huge so that everyone can see it clearly. We are now looking at some annuity symbols first. The first one, the code is a bit long. Okay, hopefully it's correct. So this is the first one. Okay, it looks like this. We usually call it a angle N. So if you study, if you don't do actuarial, it might be a bit cryptic for you, but that's okay. So in actuarial, it means the present value of a series of N payments. Just for you guys to understand the symbol more clearly, I am going to include something here. Okay, you guys don't need to worry about what I've just copy and pasted here. This is just showing you the meaning of A angle N. So it should be the present value of these $1 payments at the start, like at time 0. So apart from this one, A angle N, we can have different variations of it. For example, if we include a star or 2 stars, we will have the annuities, and this one is a continuous annuity, and this one is annuities in advance. And also we could do the same thing for accumulations. I will just copy and paste. So you can just change the A to S. It means the accumulated value instead of the present values. Okay, cool. And then you recompile, you can see the accumulations in array, in advance, and also the continuous accumulations. If you don't do actuarial, it's okay. Let's now do something fun. We could recreate the ASS symbols. The ASS symbol is very similar to one of the annuities, which is this one. You can essentially just change the N to SS. And you will have the actual symbol, the Actuarial Students Society's symbol, sorry, which is this. And just because I know how much you guys love Actuarial Students Society, now I'm going to do I love ASS. So it should be a heart suit. Yeah, I think that's correct. Recompile, and there you would have I love ASS. Okay. Apart from the annuities, there are some other ones. I will just briefly mention them here. One of them is this, which is current expectation of life, or complete expectation of life. Okay, so this is the current expectation of life, and the second one is complete expectation of life. It's like how long, it's like the expected lifetime of a person. All right, for the interest of time, I'm not going to go through all of the actual symbols with you today, and that's pretty much it I want to discuss. But however, I have made a table here. I will copy and paste it here. You can see that this is a table which summarizes some of the annuity symbols. And also, if you are interested in if you need to use more actual symbols that isn't covered in today's workshop, a good way to do it is to just Google actual symbol LaTeX, and also you will easily find this document, which summarizes pretty much all of the actual symbols. Like if you scroll down, you can see there's like a lot. So I'm not gonna cover all of them with you today. Yeah, I think. So that's it for the actual symbols. Okay, now I will stop share because I will now pass it on to Elizabeth, who is going to go through with you the next section. Let's welcome Elizabeth.
Thanks, Rose. I just want to double check that everyone can hear me and can see my screen. Okay, great. First of all, let's do some list and enumeration. So we'll start off by creating the document. So just creating an article and begin the document. We can do unordered or unordered lists. So let's say we want unordered lists. We can use begin itemize with a Z, and that will add in bullet points. So you can add in items by doing /item. So first item and second item, etc. If we compile that, then we'll see first item there. Typo. And we'll see we've got bullet points here. One thing we can do with lists is we can nest things inside. So if instead of another item, we did the same command, so begin itemize, then we can add in sub-items. So say first and second sub-item. And we'll see that nests it. We can also do ordered lists. So ordered lists. We use the command begin enumerate. And so item 1 and item 2, just like before. And it will number them. We can also nest it just like with unordered lists and using the same command again. So sub-item 1 and 2. And then that's how you get your 2A, 2B, etc. So it's very useful for maths. And that's all fairly straightforward. If we want to do hyperlinks and hyperreferences, let's start off by creating a document again. And begin document. Let's fit the title, hyperlinks and hyperrefs, and make title here so that it displays the title. We can add in some sections and subsections. So section A, subsection A1, section B, subsection B1, and let's create a new page using the new page command and a final section called hyperlinks. If we add the command table of contents, then we can compile it. Let's have a look. And we'll see contents as well as sections and hyperlinks here. Now you notice if you try and click on these, they won't take you anywhere, they're just regular text. We can add in the package hyperrefs, and if we recompile that, hyperref, sorry, we recompile that, then it will make all of these clickable, so it will take you to the relevant section. So if we click on hyperlinks, it will take you to hyperlinks. We can add in, let's say we wanted to add a sort of bibliography and add in some links. We can use the command /URL. So I'll just copy one over. So we can add in this link. Let's go to the hyperlinks and we'll see this URL displayed. And if we click on it, it will take us to that page. We'll see the LaTeX project. If we want to display a word or phrase instead, we can use the command /href. And you put the link here and what you want to display here. So let's say we want to call it the LaTeX project home. You recompile that, and then it should display here. And that will also take you to the same website. We can also add hyperreferences within the document. So let's say under subsection A, we wanted to add a reference to something down here. We can use hyperlink with the section. So if we know the number of the section, so here we know section 3 is hyperlinks, then we can say section 0.3, and let's say we want it to display a hyper. Then it will give you some text here and it will take you to that section. Now, one thing about hyperlinks is that you might not know what number the section is, and you might want to change the number of sections. So you can add in a label. So let's say I wanted to add a label here, a hyperlink section. Then we can add a reference here. So you can either use ref, hyperlink section. And then that will display a number. So I'll put that on a new line. And it will take you to section 3, which is the hyperlink section. Or we can use a slightly different command, /hyperref. And so we'll take it to the same section, hyperlink section, but we want it to display a text instead of the number. So hyperlink section here. And then text will appear here and it will take you to wherever that label is in your text. So here we've got the label here, and you can add it anywhere in your document. You can also change formatting, so different colors and whatnot, but I won't go through that. Just know that's available. So let's do some maths and equations. LaTeX, as you may know, is used a lot in maths, and there's a lot that can be done with it. Let's start off by making a document again. So article, a title, equations, and maths. Begin document, and make a title, and add in section called maths. What we want to do here is we want to use a package called AMS-Math for all the maths formatting, and has a lot of symbols, lots of math symbols. Basically, if you want to do anything using maths, you should add it in. So let's add it in here, AMS-Math. So we can use the dollar sign, so single dollar signs with an equation if we want it to be inline. So that's the inline, or double dollar signs for display. If you use the double dollar signs, then it will put it onto its own line, and single signs will put it in line. So we'll see here, we've got that here, and the display centers it and makes it a bit larger. The AMS math package has a lot of useful symbols, as I mentioned. So let's say we wanted to add some of them in. We've got the Greek symbols, Greek letters. They've got, say, /alpha, beta, gamma, etc. And it's also got capitalized versions of them. So you do that by capitalizing the first letter. So it has that for most, but not all the Greek letters. Let's use capital gamma, capital omega, and capital pi. Now it will nicely display all these symbols on the page. It's also got a number of operators. So you've got times, div, standard plus, standard minus, and also a symbol called /PM, which is for plus and minus. You've got your relational operators, so standard less than, greater than, equal to, and it's got commands for less than or equal to, LEQ, greater than or equal to, GEQ, /in for is an element of, or is inside, /ni, which is in, but the other way around. And of course, you've got your infinity, but it's INFTY, not infinity, but INFTY. If we compile those, then we'll see all these symbols nicely displayed, and you can add them into your questions. If you want to add in some of the common sets like real numbers or integers, etc., then we need another package here. We need to add in the package AMS SYMB, AMS symbols. And you can put them into your document by using /mathbb, and you can use that for R, or it's the same thing but for Z, and mathbb for, say, N and Q, and a few others. And we'll see those all nicely displayed here. You can add in superscripts and subscripts using the hatch or the underscore. So if we wanted e to the power of x, then just e hat x, or an underscore, so f underscore naught, so f naught of n. So that would give a subscript. We'll see nicely formatted again. There are a number of other things we can add in, so /sign, cos, and then you've got things like sum, which will add in the big sigma for sum, or /prod for products, /lim, and /int, and those all do what you would expect them to do. So you've got sign, cos, sum, and whatnot. Now the great thing is you can use superscripts and subscripts within these to make them even better. So let's say we wanted to do an integral, we can do /int and then do an underscore for the lower bound, and then hat and upper bound here, and f of x. Now LaTeX has the curly brackets. It uses that to consider that as all one object instead of just looking at the first one. But the regular brackets, those are just displays. So we'll see these brackets won't output, but these will. So we've got an interval there, or if we want to make it a bit larger and nicer to see, we could put them in double dollar signs, and that would put it like the display. We can also do a similar thing with limits and a lot of other things. If you want to add in a fraction, then we'll use /frac, and then the numerator and denominator. So say 1 over x. Now you don't need the dividing sign, you just make sure that each of them are in squiggly brackets. So numerator and denominator. And let's put that in double dollar signs. So we've got this nice fraction 1 over x here. And you can include whatever symbols you want. Say if you wanted e to the power of x over x, you could add it in like that. You can add spaces by using slash space or slash quad. So let's say we had x equals b, then we can add in space like this, or slash quad for a slightly larger space. And within the double dollar signs and dollar signs, LaTeX basically ignores the white space except to separate things. It doesn't add in the space to the output, which is why you need to add in these or quad. So you notice there's space here and slightly larger space here. And these were for the slash space and slash quad respectively. We can also add in matrices. So let's add in some matrices. Put this in double dollar signs. We can use the command begin b matrix. Now what that does is that adds in matrix with square brackets. If you want it to be in parentheses, then we'd use p matrix instead of b matrix. Now this is quite similar to tables. You separate the elements by using an ampersand. So you've got A and B, and C, and D, E, and F. Let's have a look at that. So now we've got lovely matrix with all of the elements displayed like this. You can add in matrices next to each other by just doing the same thing again on new line. Now, one thing with maths that's very important is aligning equations, because otherwise they can get very messy. So we can do begin align. So we'll do align with the star. Now what the star does is it means that we don't put numbers next to the equations. If we get rid of the star, then it will number all the equations, which can be useful, but not what we want to do right now. Let's say 2x plus y, use an ampersand to align them, equals 4. And then we can do a similar thing, and we want to align it at the equal sign. So 4 minus y, and so x equals, and we put it into a fraction, 4 minus y over 2. If we compile that, oops, this is an ampersand. If we recompile that, then we'll notice all of the equal signs are aligned nicely. If we don't do that, then they'll all be centered and the equal signs will be in slightly different places. You can also add in, say, implies. There's a symbol for implies, which is very useful, but we don't want that for the very first one. So implies here, and implies again. Now, if we try to compile that, it will not display exactly how we want. We can align the implied symbols as well, but align introduces them in pairs of columns. So it's trying to put all of this into the same one. We can add in new columns by using ampersands again. So this would create a new column. Let's try that. And you'll see that it's kind of a bit messed up, mainly because we didn't put an ampersand here. So it's trying to align the first ampersand here at the equals with this ampersand. So let's add in an ampersand and start and try that again. Now that's kind of a bit better, but not exactly what we want. What Rose briefly mentioned is column aligning in tables. So in the line, what it does is it puts them in pairs of columns, and you've got right aligned and then left aligned, and then right aligned and then left aligned. So it's not exactly what we want here. We want this to be next to this and align at the equals. So if we add in another column for each of these, then it should compile nicely. We'll see here the implies signs outlined, the implies signs aligned, and the equal signs outlined as well. So what the extra ampersand did was basically adding in an extra unused column. Now there are slightly different ways to use align. So there's also align at, which has similar syntax, but slightly different, and can be used if you want less of a space between the invisible columns. So can be useful, but align can be used for most of your needs. Okay, I think that's all from me. I'll pass you back to Rose to do some of the capstone exercises.
Thanks, Elizabeth. Chani, are we doing breakout rooms?
Yes, they are ready. Would you like me to split them into breakout rooms straight away? I thought you want to briefly talk about the capstone first.
I'll briefly talk about something first. So now let's move on to the capstone exercises section. So we will be putting you guys into different breakout rooms where you will get a chance to collaborate with each other. So a good way is to, once you are in a breakout room, I would encourage one person to share their screen. And also you could share your project by clicking on the three people at the top. You can turn on the sharing link and just copy and paste this link into your chat box so that you guys will have the chance to collaborate on the project. And also, here is the document that you will be trying to recreate. And I will just copy and paste the link into the chat. If you run into any problems, you could also always ask for help. And I think there will also be committee members in each breakout room.